Let's look at spin-orbit resonance. Spin-orbit resonance is periodic gravitational tugs by two celestial objects in orbit around a common center of mass that result in one or both having integer number of rotations for an integer number of revolutions relative to background stars. Here we're looking at the Earth-Moon system. Both celestial objects provide gravitational tugs that result in both objects orbiting around a common center of mass. Now, if you look closely at the moon seems to be orbiting around the Earth, and the Earth doesn't seem to be orbiting at all. And that's because in this animation, the center of mass of the system is located at the center of the Earth. So the Earth does not move, even though it does revolve and rotate. The moon revolves around the Earth. Now, if you look closely at the near side of the moon that's colored dark, which we would call the man in the moon when we look at the moon in the sky, this man in the moon, or this dark portion, appears to spin once as the moon orbits once around the Earth. So if you look very closely, it looks like we're making this circular motion for every orbit around the Earth. We would call this a spin-orbit resonance. The moon appears to spin one time around the Earth as it orbits one time around the Earth. So we would call this a resonance or a spin-orbit resonance. And this is, of course, relative to our position looking at this system. We are considered the background stars. We're attached to the background stars. We're looking in to the Earth-Moon system. We're not located on Earth. We're not located on the moon. We're well away looking at this Earth-Moon system, and from our vantage point, it looks like the moon spins one time relative to orbiting one time around the Earth. This spin-orbit resonance, we generally put in parentheses with an S:0, and in this particular case for the moon, it would be one spin for one orbit, so the spin-orbit resonance is 1:1. This is one example of a spin-orbit resonance. Another example of a spin-orbit resonance is Mercury's spin to orbit around the Sun. So in the case of Mercury, it actually spins 3 times for every 2 times it orbits the Sun. So if you look very closely at this red arrow, you'll see that the arrow makes 3 complete spins for every 2 times Mercury orbits around the Sun. We would call this a 3-to-2 spin-orbit resonance.